In this example, or in this set of videos, or one more try. In this video, I'm going to work through numerous examples involving the concept of latent heat. So for our first example, how much less energy? So when you see a question that says how much less, right, this should get you in the idea that we're going to be subtracting in the end. Okay, energy is needed to convert 50 grams, that's a mass, of solid aluminum to a liquid, as compared to converting another 50 grams of liquid aluminum to a gas. So let's do the first part first. We want to convert a solid to a liquid. To do this, we use the latent heat formula. The energy needed is the mass multiplied by the latent heat. For these examples, you're going to need access to the table that's in Sakai, or it's also in your book. For aluminum, when you're going from solid to liquid, the latent heat is 94.6 calories per gram. So Q equals 50 times 94.6, which is 4,730 calories. When we go from a liquid to a gas, the formula we use is the same, but we've got to use the latent heat for vaporization, the one associated with converting from a liquid to a gas. For aluminum, that value is 2,600 calories per gram. So Q is going to be 50 times 2,600, which works out to be 130,000. So how much less is needed? We take 130,000 calories, subtract off 4,730 calories, and that is 270 calories, which might be surprising to you. It takes a lot more energy to go from a liquid to a gas than to go from a solid to a liquid. This is, as far as I know, universally the case. For the second example, we're just going to melt an ice cube. So we need, for our latent heat, the latent heat of fusion for water, and that in the table is given as 79.8 calories per gram. The mass we're given as 10 grams up here, so that's 10 grams times 79.8 calories per gram. Therefore, it takes 798 calories. For example 3, we're wanting to boil gold. When you're boiling, that means you're going from a liquid to a gas. Right. For gold, the latent heat is 409 calories per gram when you are converting from a liquid to gas. So same formula, Q equals ml. The mass is 100 grams. The latent heat is 409 calories per gram. So that's 40,900 calories are needed to boil 100 grams of gold and convert it completely over to a gas. The last example we do here is actually combining the specific heat stuff we learned last video with the latent heat stuff we're learning here. So we're wanting to take 100 grams of ice that is at its freezing point, 0 degrees Celsius, and completely convert it to steam at 100 degrees Celsius. So the mass is going to be 100 grams. This is going to be our initial temperature, 100 degrees Celsius. This will be our final temperature, 100 degrees Celsius. And we're working with water. Therefore, we need to know the values for the latent heats and the specific heats for water. Those can be found in the table. In order to work this, you have to do it in 3 parts. The first thing you need to do is convert the ice completely over to water. This involves the latent heat of melting or fusion, sometimes it's worded as. Once it's all water, you can then raise the temperature of the water. We do that using specific heat. And then once it's up to 100 degrees Celsius, we convert it completely over to steam. That requires the latent heat of vaporization. Let's do the first step. So how much energy does it take to melt 100 grams of ice? So as I said, it's our latent heat formula. The mass is 100 grams. And for ice, the latent heat is 79.8 calories per gram. So that's 7,980 calories. I'm going to call this Q1 because it's the first step. Next, we have to raise the temperature of our water. To do that, we use the specific heat. So Q equals M delta T times C. Our mass is 100 grams. You might look at it and say, hey, the change in temperature is going to be from 0 to 100, that's just 100, but let's do it formally. T final is 100 degrees Celsius, T initial is 0. And the specific heat for water, you might recall, is 1 calorie per gram degrees Celsius. When you multiply those together, you get 10,000 calories. Because this is the second step, I'm just going to call this Q2. And for our third step, we are going to convert to steam. So that again is the latent heat formula, Q equals mL. It's still a 100 gram sample. In this case, the latent heat is 539 calories per gram. And when you multiply those together, that's 53,900 calories. Because this was our third step, I'm going to call it Q3. So going back to the original question, how much energy does it take to take 100 grams of ice and convert it to steam? We add the 3 steps together. So Q total will equal our Q1 plus Q2 plus Q3, which is 7,980 calories plus 10,000 calories plus 53,900 calories, and that all works out to be 71,880 calories.